All right, so lesson 3, we're going to jump ahead in our book to 1.4, and we're still going to be solving linear systems. So we're going to be trying to find out x and y using algebra again. And this is an alternative to the substitution method that allows you to find out your x's and y's. So this is the third method called the elimination method. So what we're going to do is first we're going to express both equations in the form ax plus by is equal to c. That was called standard form. We want both equations written in that form. Even if it's written as mx plus b, we're going to rearrange it so the x term is first, the y term is second, and the c or constant term is by itself. Next, we're going to choose which variable to eliminate, multiply as required to achieve the same coefficient with the same variable. So I want to have the same number in front of either x or y. Doesn't matter which one, I choose which one, but that's what we're going to do. Then we're going to add or subtract those x's or y's in order to eliminate one of the variables and hopefully get 0. So for example, if I have 2x in front of, or 2 in front of both my x terms, I would subtract them because I want to get 0x. I want to eliminate x so x is gone. If I have something like 2x and negative 2x are my coefficients, in that case I'd want to add them because that will result in 0x. You want to eliminate x. You want to get the same number in front and eliminate by adding or subtracting. Then we're going to solve our new equation that we get when we add or subtract the two linear equations from each other. And then just like before, we're going to substitute our answer back in to solve for the other unknown. So let's look at an example here. Solve the following linear system using elimination. So right now the coefficients on x are 1 and 1. The coefficients are 1 and 1 on y, although it's negative 1. The numbers are the same in front of x and y. So I can decide here which one I want to get rid of. In this case, maybe I'll try to get rid of the x's. I'll try to eliminate the x's. So what I'm going to do is just look at these and decide if I'm adding or subtracting those, which one will eliminate x and give me 0. So if I'm adding x plus x, I would get 2x. So that's not what I want. I want 0. So what we're going to do is we're going to subtract them. So when I subtract them, I'm going to subtract all the like terms together. So I'm going to subtract the x's. X take away x, well that's 0x. Then I'm going to subtract the y's. Remember the sign in front of the y matters. We're taking 1y subtract negative y. So when we write that out, it's like this. Y subtract negative y, which is 2y. Positive 2y, because 1 take away negative 1 is 2. And then I'm going to do the same on the right side. 8 take away 2, well that's 6. And now I have a new equation. Because the x is 0, it's gone. I just have 2y is equal to 6, and I solve that by dividing both sides by 2. I get y is equal to 3. So a lot of times this is a very simple method, very quick method. Now what I'm going to do is I'm going to try to find out what the other variable is. So I'm going to take y is equal to 3 and put it back into one of the equations. It doesn't matter which one or the other. Both will give me the same value. But I'll take the first one. We have x plus y is equal to 8. But I know y is 3, so I'm going to have x plus 3 is equal to 8, and I'm going to try to solve that one through. I'm going to bring 3 to the other side. When I bring to the other side, I have to subtract, and we get x is equal to 5. So I've solved my system. I know what x is, it's 5. I know what y is, 3. I can always test doing that formal check, and I use a different color for that. If I test that first equation, x plus y is equal to 8, and I substitute an x and y, well, x is 5 plus y is 3 is equal to 8. 8 is equal to 8. That's a good one. I'm happy about that. We'll try the second equation, which is x minus y is equal to 2. If I put in 5 for x minus 3 for y is equal to 2, I get 2 is equal to 2. I'm happy about that as well. So I know that I did it correctly. Those two numbers, x is 5, 3 for y, are the only values that make both equations balance. So that would be the solution to this system. I would get the same answer if I use substitution. I would get the same answer if I use graphing. It's just a different method, and we'll go through later on how do I choose which one's best. So let's keep rolling along here. Solve the following linear system using elimination. So I'm going to rewrite this one out. So 3x minus 2y is equal to negative 5. I like to rewrite it out so that the numbers are directly under each other because they're kind of sideways here a bit. Next one, I have x minus y is equal to negative 2. So the first step is we want to have the same coefficient in front of one of our variables. This is where we decide. Right now I look at this one and I see 3 in front of the variable on top and 1 in front of my variable on the bottom. So they're not the same. I look over here and I see that the variable on top has a negative 2. The variable on the bottom has a negative 1. So they're not the same. So I need them to be the same. So one thing that we can do is we can take the bottom equation and multiply the entire thing by a certain value that will make it match. So like for example, if I want the x's to match, have the same coefficient, I'm going to have to multiply the entire bottom equation by 3. If I want the y values to match, I could multiply the entire bottom equation by 2. Does not matter which one you choose. In this case, I'll eliminate x. So I'm going to take this bottom equation and I'm going to multiply the entire thing by 3. The top one, I'm going to keep it the same. So I'm actually going to write multiply by 1 just to show that now I have my new equation, 3x minus 2y is equal to negative 5. So we're stacking them on top of each other. For the bottom one, I'm going to multiply each of them by 3. So 3 times x, 3x. Then I'm going to do 3 times negative y, which is negative 3y. And then 3 times negative 2, negative 6. So now I have an equivalent linear system that has what I want. I have those variables that have the same coefficient. Now I'm going to have to decide, should I add or subtract these in order to get rid of the x? So look over here on the right. Will adding those or subtracting those give me 0x? Well, adding won't work because 3 plus 3 is 6. So I'm going to have to subtract. So when I do that, I'm going to subtract every like term that exists here. So 3 take away 3 is 0x. Negative 2 take away negative 3 is actually positive 1y. You might say, well, how do we get that, all those negatives? Well, essentially what we're doing is negative 2y take away negative 3y. One thing you might remember when you're subtracting a negative, that's the same as adding. And that's where we get that positive 1y from, because it's really negative 2 plus 3 because we're subtracting a negative. Same is going to happen for the next one here. We have negative 5 in the top. Take away negative 6. So it's really negative 5, take away negative 6, which is like negative 5 plus 6. So the answer is going to be 1. So we'll put that in, positive 1. That gives me my new equation here. I have y is equal to 1, because this term is gone. 1y is equal to 1. Divide both sides by 1, I guess, if we want, but regardless, I'm going to get 1y is equal to 1, or y is equal to 1. That's my first variable. Now what I need to do is find out what x is. So what we're going to do is we're going to take our y is equal to 1, and I can substitute it in here, or I can substitute it in here. to find out what x is. I could even, because they're equivalent, I could even substitute in for y here, or substitute in y here. Doesn't matter, they're all the same. All will give me the same answer. So that's what I'm going to solve now. I'm going to take the first one just because it's on top. 3x minus 2y, which is 1, is equal to negative 5. And I'm going to use that to solve for x. We simplify it. I'm going to bring 2 over to the other side, when it's going to have to change its sign. And divide both sides by 3. I'm going to get x is equal to negative 1. So that's my solution to this system. X is negative 1, y is equal to 1. We have our two variables that we solved for using elimination. We eliminated the x variable, solved for y, and then I used that y variable to substitute back into one of the equations to solve for x. It would not matter which one I substitute that y is equal to 1 into. I could have substituted into any of them. I could have substituted in here like we did. I could have substituted in here. I would have still got negative 1. Or I could substitute it in here, y for 1. Or I could substitute in here, y for 1. It didn't matter. You're going to get the same answer. All right, so you're getting the hang of it here. This one will be a little bit faster. I'm going to rewrite it out so that they're lined up a little bit better. But this new system here has an extra step to it. And you maybe you'll see why here. Maybe you already do see why. Now I want to get the same value coefficient in front of one of the variables. So if I look at the first ones, the x's, it's not so easy. There's no number that I can multiply 3 by in order to get 10 right away. How about for the y values? Oops, erased one there. How about for the y values? There's also no value that I can multiply just one of the equations by to get the other. Maybe 1.5, but then we're going to have a lot of decimals in there. We're looking for some whole numbers, so I can't do that. So what we're going to have to do in this case is multiply both the equations. So in this case, we'll eliminate y. It doesn't matter which one we get rid of, but I'm going to eliminate y just because we eliminated x in the first couple. But what I want to do is find a common multiple between 2 and 3. The signs don't matter when we're doing this. In this case, it's 6. So I'm going to take the entire top equation and multiply it by a factor that will give me 6 in front of my y. In this case, I'm going to choose 3 because 2 times 3 is 6. And the bottom equation, I'm going to multiply it as well by a factor of 2 so that I'm going to get 6y because 2 times 3 is 6. So I'm going to have to do that for each term in that equation. So let's make our new equivalent linear system. So I'm going to multiply 3 by the first term, 3 by the second term, and 3 by the constant term. When I do that, I'm going to get 9x minus 6y is equal to 6. And on the bottom, I'm going to multiply each term by 2. I'm going to get negative 20x. I'm going to get positive 6y. And I'm going to get equal to 16. Now we have our equivalent linear system where we have the same number. Don't worry about sign, number in front of our y value. Now we're going to have to decide what do I have to do to these numbers in order to eliminate it. What will give me 0? Because I want 0 as my result. I want to eliminate y in this case. So does negative 6 plus 6 get rid of it, or does negative 6 minus 6 get rid of it? Well, plus 6 will get rid of it, so I know I'm going to be adding all these terms. If I subtract, then I would have negative 12. That's not what I want, so I'm going to add all the like terms. Oops, I erased one there. So let's go through. First one, 9 plus negative 20. So 9 plus negative 20 is negative 11. Negative 6 plus 6 for the y's gives me 0. I don't even need to write it, but I will write it here. And then on the right side, 6 plus 16, 22. That gives me a new equation because the y has been eliminated. I now have negative 11x is equal to 22. And when I divide both sides by negative 11, I'm going to get negative 2. Now I need to find out my y variable. I know what x is. X is negative 2. So what I'm going to do is I'm going to take that negative 2 and I'm going to substitute it back. I can either put into this equation here, or this one, or this one, or this one. It doesn't matter. We know what x is. Any of those will give us a value for y. So I'm going to take the first one once again just because it's the first one, and I'm going to substitute in negative 2 for x. So we're going to start 3x, which is negative 2, minus 2y is equal to 2. I'm going to solve that for y. Negative 6, take away 2y is equal to 2. 6 is going to go over to the other side. We're going to have 2 plus 6 because that's to change signs. Negative 2y is equal to 8. And when I divide both sides by negative 2, we're going to get y is equal to negative 4. We've solved our system. X is negative 2, y is equal to negative 4. So this one was a little bit different than the first ones that we saw because both equations need to be multiplied by a certain factor, 3 and 2, in order to get them to match. And that's as difficult as they're going to get. Until we see this. This one here, the first one is in proper form. The second one is not in that proper form of that ax plus by plus c. So I'm going to rewrite that first one out. Always gets a little more difficult when we have fractions involved. However, we know a little trick in order to get rid of them. What I'm going to do is simplify this to put it into standard form. So I'm going to have to distribute inside the first bracket. And then keep my x first, which is 3x. Keep my y second, which is negative 2y, and bring everything else over to the other side. Minus 3 and minus 6. 3x minus 2y is equal to 2. So this here was just a fancy way of writing our equation in standard form, like this one. So I'm going to rewrite it down below, the other equation here, because usually we write one on top of the other when we do our linear systems by elimination. So this is what we're trying to solve. So we look at this one and say, well, I see all those fractions in there, and usually I don't like fractions. I know that I can get rid of those fractions by multiplying everything by 3. That might be a first step that you take. Or maybe you say, well, I want to get the same coefficient in front of, let's say, one of the variables. Let's choose, I don't know, the first one. Doesn't really matter. I know that a common multiple of those is 6, which means I'm going to be multiplying the top equation by 3 and the bottom equation by 2, so that I'll get the same coefficient in front of my x's. And that's a good choice because I know that when I multiply by 3, that's going to make this 1 over 3 times 3 to be 1. That's going to make this also to be 1, which is a nice whole number, and that's going to get rid of all of our fractions. So that's a good choice. So let's do that. I'm going to multiply the first, second, and third terms by 3. So we're going to get 6x minus 3 times a third is just 1. And on the right side, 3 times a third is also just 1. On the bottom, multiply everything by 2, so everything will be twice as big. 3 becomes 6. Negative 2 becomes negative 4, and 2 becomes 4. Now I can eliminate. So think to yourself, should I add or subtract these in order to eliminate x? Because we have the same coefficient in front of x, that's why we decided. This one is not plus, because 6 plus 6, 12. That's not what we want. We want to eliminate it, 12x. We want it to be 0, so I'm going to subtract, because 6 take away 6 is 0x. Next one, negative 1y, take away negative 4y is positive 3y. Once again, it's negative y, take away negative 4. Negative y, when you subtract a negative, is like adding 4y. So it's negative y plus 4y almost, and that's where we get the 3y from. And finally, 1 take away 4 is negative 3. Right, we're subtracting all of these from their like terms. That leaves me with the new equation. 3y is equal to negative 3, and I divide by both sides by 3 to get y is equal to negative 1. And now I put that back into one of my equations. Here is where maybe you use a little bit of thinking and say, you know what, I'm not going to substitute this one into the first one because I don't want to work with fractions. I'm just going to substitute in the second one because it looks a little bit easier. So do that. 3x minus 2y, so we know y is negative 1, is equal to 2, and makes our life a lot easier when we can choose proper equation to work with. 3x is equal to 2 take away 2. 3x is equal to 0, and divide both sides by 3, we get x is equal to 0. And we are done. We have an x value of 0 and a y value of negative 1. That's the solution to that more difficult linear system where we had to do a little bit of work beforehand. And finally, we have a word problem here. This one says the owner of 2 hotels is ordering towels. So there's 2 towels he's buying. He bought 30 hand towels and 76 bath towels for his hotel. The total was $774. He also ordered 99 hand towels and 70 bath towels for his hotel in Campbell, and he spent $927 that way. How much does each towel cost? So we can make up our variables. Maybe we'll say H will be cost of hand towels. We could say B could be the cost, I shouldn't say hand towels because it's just one, of bath towel. Right, because it's going to give us the individual cost. So now we're going to make equations. So we're going to put these together. 30 hand towels, 76 bath towels. It cost him $774. So he paid H price 30 times, plus he paid B price, whatever that is, 76 times, and it cost $774. This other guy, he bought 99 hand towels, so he paid 99 H's and 70 B's for $927. So now you can see where these ones can get a little more difficult when the numbers are big and they don't work out so nicely. That doesn't mean we can't solve them. We don't have the same coefficient on our variables here, so I'm going to have to choose a number where they would be the same. So let's take the first one maybe. 30 and 99. Maybe a number doesn't jump out right away that you see that they have in common. So a little bit of a shortcut might be to say, well, I know I'll get a common multiple if I multiply 30 by 99 and if I multiply 99 by 30, right? Just by the other multiple. So the numbers are going to get quite large, but you're going to see that a lot will cancel out. So we'll do that. So in our calculator, we're going to put in 30 times 99, because I know that's going to work out to be the same coefficient for both of them. So when I put in 30 times 99, we're going to get 2,970H. I'm going to have to do the same thing for 76. When I multiply it by 99, I'm going to get 7524B is equal to, and finally 774 times 99, we get 76,626. I'll zoom in there shortly once we get the other one. And then we'll multiply all the other ones by 30. So 30 times 99, we already know that that one's going to work out to 2970H, plus 70 times 30, that's 2,100. B is equal to 927 times 30. That's 27,810. So this is all we're really concerned with right now. These ones are B's. Kind of look like sixes. But now I'm going to decide, should I add or subtract these ones together? Hopefully you're saying, yeah, we subtract these, because I know when I subtract those H's, we're going to get 0H. If I add them, I'm going to get a very big number. So I'm going to have to subtract all of the like terms that we have. So for the B's, I'm going to be subtracting the number on top, 7,524, and taking 2,100 away from that, which is positive 5,424B. We're going to do the same thing for the numbers that are on the right, 76,626, take away 27,810. And we're going to get 48816, 48,816. So now we have our new equation because the H is gone. 5,424B is equal to 48,816. And when I divide both sides by 5,424, I get B is equal to 9. That means bath towels cost $9. Now I want to know what it costs for hand towels. So I'm going to take B as 9, and I'm going to substitute back into one of these equations. I'll take the first one just because it's the first one, but 30H plus 76 times 9, because they bought 76 hand towels at $9, and the total was 774. And I'm just going to solve for H. I'm going to multiply 76 times 9, and we get 684. That's how much all the bath towels cost. I'm going to bring that over to the other side. 774 take away 684. 774 take away 684, and we end up with 90. So 30H is equal to 90 when I add those like terms. And divide both sides by 30, I'm going to get H is equal to 3. So that means they bought hand towels for $3. They bought bath towels for $9. And I can write a sentence. Therefore, hand towels cost $3. Those are the small ones. And bath towels cost $9. And there we go. So that's the idea behind the elimination method. You're trying to get rid of one of our variables. You need to get the same coefficient in front of those variables once you've lined them up into H's or X's first, Y's second, and all the constant numbers on the right side. Get the same coefficient by maybe multiplying one or two of your equations by some constant. and then deciding, do I add or subtract in order to eliminate that variable? That's going to be the one that most people have trouble with, deciding whether they add or subtract. A lot of times they just think they subtract. But if both the coefficients have the same sign, they're both positive or both negative, we're going to subtract. If they're opposite signs, like this one here, the 6's were opposite signs, we ended up adding. So that's one kind of a shortcut to look at it. And once we've done that, you solve it for one variable and then substitute that back into one of the equations to find out the other variable. And if it's a word problem, we need to write out our sentence at the end. But that's elimination. If you have any questions, be sure to let me know.